We break it down with tips and tricks that'll earn your crown. In equations, logic, step-by-step game. It's all made easy. It can explain, so like, subscribe and join the ride. Math is magic on the smart side. Calculus, differential equations, mechanics, electricity. All your math and engineering questions, answers are here for you all day. Engineer Akin explains. Engineer Akin explains. Learn and know a lot.
So E times cosine F. So wala 2 pi. Wala na next. F 2 pi na wala to.
Okay, so now we will be discussing AC motors. Okay, so we'll be discussing about yung mga iba't ibang type ng AC motors, from single phase to three phase, and also the ways in controlling our AC motors. Okay, so let's start discussion. So first we'll be having the types of rotor as the construction. So we have two types. Yung pinakauna po is yung squirrel cage type. No? The motor consists of aluminum bars located in slots in the iron core, unconnected to one another by means of heavy cast aluminum rings located on both ends of the core. So yan po yung squirrel cage, no? Kung bali po, kaya po siya tinawag na squirrel cage is kasi para po siyang squirrel cage o yung cage ng squirrel, no? Kasi yung slots niya, which is consists of aluminum bars, no, is similar to a cage of a squirrel, no? Then one rotor, so the rotor windings that are connected to a commutator. So yung rotor natin meron siyang winding. So sa term pa lang na one rotor, so ibig sabihin yung rotor natin ay may mga windings, no, that are directly connected to our commutator. Then the first type of single phase motors that we are going to discuss is the capacitor motor. So it is a single phase induction motor that uses a squirrel cage rotor and a stator that has two windings called the main or running windings and the start or auxiliary windings. So the direction of rotation is reversed by interchanging the connection to the start or to the run windings, no? So yung mga basic parts po ng capacitor motor, so syempre meron tayong rotor, stator, in place or brackets, centrifugal device, stationary switch, and one or more capacitors, no? So yung ating capacitor motor, so it has two types of winding. So the first winding is called as the main or running winding, and the other one is a start or auxiliary winding. So usually the auxiliary or start winding is the winding that is used, no, during the start of the motor. Then depending on the condition, the centrifugal device or switch will kick in, thereby disconnecting, no? Disconnect po yung starting winding para ang tumakbo na lang is yung main or running winding or run winding. Then we have the capacitor start motor. So that is an electrolytic capacitor is inserted to our capacitor start motor. So doon po siya nilagay sa ating start winding. So the motor is equipped with a centrifugal switch that disconnects the start winding after the rotor has accelerated to about 75% of its rated speed, no? So isabihin po natin, yung motor po natin ay meron siyang capacitor na connected sa kanyang start winding. Tapos it is also equipped, no? Meron pa siyang centrifugal switch that disconnects, no, our starting winding if the motor is now running at 75% of its rated speed. Then we have the permanent split capacitor motor. So this is a capacitor having no centrifugal switch, meaning yung ating capacitor is connected, no, throughout the operation. So it uses an oil-filled type capacitor instead of an electrolytic type, no? Yung sa capacitor start kanina, yung ating capacitor is electrolytic. Dito sa permanent slip capacitor, that is ang ginagamit po is oil-filled or oil-filled type na capacitor. Then we have two value capacitor motor. So that is a capacitor motor using different values of capacitance for start and running windings. So ibig sabihin nito, yung ating starting winding meron siyang capacitor, same operation po sa ating capacitor start, that at 75%, ang gagana na lang is yung ating running winding, na kung saan din meron din siyang sariling capacitor, kaya 2 value capacitor start motor. The other name for this type of motor is capacitor start, capacitor run motor. Habang ito naman, itong capacitor start motor, the other term for this one is capacitor start induction run motor. Then we have repulsion start induction motor. So this is one of the oldest single phase induction motor and were widely used from 1930s through 1950s. So the rotor has a standard DC armature winding, a commutator of special design, and a centrifugal mechanism for short circulating all the commutator bars when the motor approaches its rated speed. So the main feature of the repulsion start motor, induction motor, is wala po to siyang capacitor, and it is one of the oldest, pinakaluma na mga types of single phase motor. So gawa ito 1930s, which is usually used 1930s through 1950s. So ang kanyang rotor is a standard DC armature winding, may commutator at may centrifugal mechanism for short circuiting yung ating commutator once the motor is now running at its rated speed. So the features of this motor is it has a high starting torque, low starting current, it is capable of doing well on low voltages, and most expensive of all the single phase motors. So kaya hindi ito masyadong ginagamit kasi sa kanyang disadvantage, which is very expensive compared to other single phase motors. Then universal motor, so it is basically a series DC motor which is especially designed to operate on single phase AC as well as DC supply. So the direction of the rotation is reversed by interchanging the connection between the armature or the field winding. So this is a motor that could run on both AC and DC. So AC single phase, DC natin pwede din siya. So this is usually used on portable tools such as electric drills, saws, and also in basic home appliances such as blenders, mixers, vacuum, and cleaners. So the features for this type of motor is high speed and also small in size. Then we have the standard HP rating of a single phase motor. So ito po kanyang mga ratings. So the smallest one is 1/6 HP, 1/4, 1/3, 1/2, 3/4, 1, 1 and 1/2, 2, 3, 5, 7 and 1/2, and 10 HP. Yung 10 horsepower po ang pinakamalaki na rating ng ating single phase AC motor per standard. Okay, so if you will question this one, so which of the following is not the standard size of a single phase motor? So the correct answer for this one is letter A, which is 1/8. Then we'll go to the 3-phase squirrel cage motor. So basically this is just the same an induction motor, but the supply voltage now, our supply is a 3-phase. So the direction of our motor, direction of the rotation, yung pag-ikot niya, ay maaring ma-reverse if we are going to interchange any of the two lines of our terminal windings of the motor. So the first type will be the one rotor induction motor. So consists of a rotor core having 3 windings in place at the conducting bars of the squirrel cage rotor. So the advantage of having windings in the rotor is that the wires can be brought out through the slip rings so that the resistance can be added, and therefore the current through the windings can be controlled. So yung one rotor, sobrang dali po niyang i-control kasi pwede po natin siyang yung kanyang wires na pwede natin ilabas sa slip ring so that we could control the current flowing inside our motor, so that we could also be able to control the starting current of our motor. Okay. Then the standard HP for these motors, yung one rotor at squirrel cage 3-phase motors. So we have the smallest size is 1/2, habang pinakamalaki naman is 200. Then we have the synchronous motor. So the basic parts are similar to a three-phase synchronous generator. So the motor needs a DC voltage to excite the rotor winding. So the features, so under normal condition, it runs at a constant speed and it can be used to improve the system power factor. So the standard HP rating of our three-phase synchronous motor, so we have 25, 30, 40, 50, 60, 75, 100, 125, 150, and 200 HP. Then we will go to control equipment. Okay, so bago yan, so sa mga gusto pong makakuha ng ating PDF copy ng ating presentation sa video ito, so the password is industrial, puro capital po yan, and the link is on the description of this video, sa baba po ng video na to. Okay, so let's proceed. Then we have the motor control system. So basically this is a system in which the electrical energy used to run a motor and a majority of the devices used to control that energy are in the motor controller or being controlled. Kino-control po nito yung power na napupunta po sa ating motor. So devices under the motor control system, we have two po. The power circuit group. So these components carry the rated voltage and current needed to operate or run the motor. So these devices commonly include disconnect, power conductors or wires, fuses, circuit breakers, magnetic contactors, rigid metal conduits, overload heaters, and others. So basically the power circuit group consists of the components that are used to control the motor itself. Habang yung control circuit group naman, so these components are necessary in switching power to the motor, either on or off, under certain conditions. So this device may include the start and stop buttons, relays, limit switches, other sensors indicating devices such as pilot lamps, alarms, and others. So the control circuit group basically is the one controlling the power circuit group. So nandun po yung lahat ng mga controls, yung mga buttons na kailangan nating i-push or i-activate in order to control the power circuit group, thereby controlling also the motor itself. Okay, so the components of a motor, so main motor controller pala. So mainly we have a contactor, so that is these are electromechanically operated switch that provides a safe and convenient means of connecting and interrupting branch circuit. Then buttons, so this type of fan switches are a two-position device operated with a button that is pressed and released. Then selector switch are actuated with a rotary knob or a level of some sort to select one or two more positions. The limit switches, so these are operated by machine motion, so they are useful in automation and control applications. Then we have control relays, used as auxiliary devices to switch control circuits and large motor starters and contactor, and to control small loads such as small motors, solenoids, electric heaters, pilot lights, and other relays. Then we have pilot lights, so these are small mushroom shaped bulb used as signaling device. At yung timer relay natin, so these are timer delay relays, which are divided into two classification, the on delay and the off delay relay. So the contacts of this relay or delay on changing their position for some period of time. So yun po ating mga components ng ating motor controllers. Then we go to the different types of motor starters. So motor starters are usually used to control the starting parameters of our motor, thereby protecting the motor itself, especially from the starting current, which is 6 to 8 times the full load current. So the direct online or DOL, so that is the simplest form of motor control. So it doesn't basically control the starting current. So the components are just a breaker and a contactor, and also a button, a push button. So then also the electromagnetic contactor has also its own overload relay under fault conditions. So the advantage, so it is cheap and economical. simple to establish, operate, and maintain, simple control circuitry, easy to understand and troubleshoot. It provides 100% torque, and at the time of starting, only one set of cable is required from the starter to motor, and motor is connected either on delta or the motor is connected on delta at the motor terminals. So the disadvantage itself, so it does not reduce the starting current of the motor. High starting current, so very high yung current natin, which is 6 to 8 times the full load current. Mechanically harsh, so thermal stress on the motor, thereby reducing its stress life. Voltage dip, no, sa sobrang taas po nating starting current, kaya nagdi-dip din po yung ating voltage, no, supply voltage. Then high starting torque, no, so meaning sa sobrang taas nating current, so the starting torque also, no, is very high. Then features, no, so usually this type of motor starter is used for low and medium power 3-phase motor, and the connection lines must be 3, no, either star or delta. Then high starting torque, very high mechanical load, high current peak, voltage dip, and simple switching devices, no. So direct online motor is suitable for a direct online starter if the inrush current, no, of the motor does not cause excessive voltage drop. So kapag hindi masyadong mataas yung kanyang voltage drop, no, once ma-start yung motor, so pwedeng gamitin yung direct online. So for example, a utility may require our customers to use reduced starters for motors larger than 10 kilowatts, no. So hindi yun pwede, no. DOL is sometimes used to start small water pumps, compressor fans, and conveyor belts, no. So direct online is not suitable if our peak current would cause, no, serious voltage drop. The equipment being driven cannot tolerate the effects of high peak torque, and the safety of comfort of the using the equipment may be compromised by sudden starting, no. For example, escalators and lift, no? So at the escalator, hindi yan pwede gamitan ng direct online. Then we have also auto transformer starter. So this uses, no, auto transformer. So at auto transformer is a transformer in which the primary and the secondary winding are connected. So the most popular electromechanical reduced voltage starter, no. So its popularity is the fact that the starter, no, can reduce the inrush current. In addition, so the taps also could permit adjustment to the voltage of our motor, and it is suited for starting most industrial loads. Okay, the advantage, the transformer starter limits significant inrush current, of course, kasi kinokontrol natin yung voltage ng ating motor. So it is used for large motor in which start by direct connection to the network is not possible. For large motor also, star delta starter cannot be used, especially if they are started with a significant load. Then the circuit has an advantage over starting with regular transformer. Then the most effective ratio of the transformer is between 65 to 80%. High torque per ampere of the supply current, motor current larger than supply current. Then these methods, no, is suited for long starting periods, and the adjustment of the starting voltage by selection of the proper tap of the auto transformer. So madali natin i-change, no, yung ating starting voltage, no, by just changing also the tapping of our auto transformer. Drawbacks or disadvantage, no, so the circuit is quite complex and involves relatively expensive auto transformer, so medyo mahal to. Then due to physical size of the whole device, it might not be possible to add additional starter on a existing machine, no, especially if our controller space is scarce or limited. Then of course, this is a transformer and it's an inductive device. It could cause low power factor. Then we have the primary resistance starting. So in the resistance starting of a motor, reduced voltage is obtained by the primary resistance starter by means of resistances that are connected, no, in series with each of the motor stator sa stator lead during the starting period. So the voltage drop in the resistor produces reduced voltage at the motor terminals, so thereby, slowing down or having a lower starting current, no? So ibig sabihin nito, yung ating resistance po ay connected, no, on or in series with our rotor or our stator, no, during starting. Okay, so advantages, no? So it provides a closed transition starting, resulting in smooth starting without any transition high current. So ibig sabihin from start, no, so nakakonect yung resistance which is in series, then to running, so there is no such thing as bigla siyang hinto, no, because of the transition. So smooth, no, parang hindi man lang nagbago from starting to running. High power factor, of course, because we are connecting a resistance, no, hindi po tayo nagko-connect ng inductive load. Absence of line harmonics, no, same with the reason, no, kasi dito inductive load, and it allows the motor to be started while on load. Disadvantage of resistance starting, it is usually very bulky and expensive when compared to other methods. It has a very high maintenance cost. A considerable amount of heat is generated through the resistor when current runs through them, and the starting frequency is limited. Then we have the most common, no, reduced voltage starter, which is the Y delta. So typically delta starter are used for motors rated above 5 kilowatts. So you can learn, no, the fundamentals of this one, no, by knowing the operation of our delta starters. So first and foremost, no, 6 to 10 po ating full load, 6 to 8, no, depending on the type of motor. The delta starter can help reduce the starting current by 33%, no, or 1/3, no. So the parts of the delta starter or Y delta starter, so we have the fuse or circuit breaker for short circuit protection, the contactors for switching, the timer relay with the delta timer to switch between Y or star and delta connection, overload relay for the overload protection of our motor. So yan po ang kanyang component. So the advantages, no, the cheapest method to start a motor, so mas cheaper to compared sa auto transformer and a primary resistance, no, na starting. The starting current is at 33%, no, compared to the direct online. Better torque per ampere of line current than the other starters. Delta starters do not require any voltage reduction equipment, so hindi po nangailangan ng transformer to reduce the voltage itself. In open transition, no heat is produced, no? So during the starting, wala pong heat na produce kasi wala po tayong kinoconnect na resistance, and the size of the overload relay can be reduced to 50%. Disadvantage, no, so due to current reduction, so torque is also 1/3, no, sa compared to the direct online starting torque. So 1/3 lang po ang kanyang torque. Then dapat yung motor mo is 6 terminal so that you could connect that one in Y and in delta. Break-in supply to the motor during transition from start to delta or from Y to delta. So magkakaroon po ng kunting tawag doon, magkawala ng supply, no, momentary loss of supply if our controller will change from Y to delta, and nangailangan ng maraming cable. Okay, so yan na po yung ating discussion for AC motors and its controller. So again po, yung password po sa ating downloadable PDF copy is nasa akin na po, nasabi ko po kanina. So you could download that PDF copy po doon sa ating link sa baba ng video na ito. So of course, I hope you learned something for this video, and always enjoy learning.